of the chapter motion in a plane. So till now you have understood about the chapter, that is motion in a straight line, where we dealt with the particles moving along a straight line, whether forward or backward. In that case, we generally treated the direction as positive or negative. That if the particle was on the right side of the origin, as you can see here, it was treated as a positive direction, and when it was towards the left side, then it was treated as a negative direction, and which kept our calculations very simple. But now, suppose the particle is not moving along one direction and it is moving in a different line, let's suppose in this manner, where you can see there's a change in position in x-axis as well as y-axis. So in the previous chapter, we limited ourselves to the study of positions when the change of position in a given time interval was only along one axis. Now, we are going to deal with such cases where the position will change along x and y axis simultaneously in a given time interval. Now, what change will it bring to us? We have to observe it. But before we move ahead, I just want to ask you a question. That suppose you have a tumbler in which you have 4 liters of water, and then you add 2 more liters to it. What would be the volume? Of course, it would be 6 liters. Now, it's a very silly question to ask. But let's change the direction. Suppose there is a particle which moves 4 meters towards north and then took a right turn and moved towards east for 3 meters. Now, what is the displacement? Now, there are 2 different terms. One is distance, one is displacement. For till now, it was easy for us to term it in positive and negative. But in this case, where the particle has moved towards right, definitely it's something different. Yes, it's not a motion in a straight line. Rather, it's a motion in a plane. The moment it took a right turn, it turned itself into a motion in 2 dimensions. Yes, that is the motion in 2 different axes in the given time interval. And in this case, you cannot simply add it as 4 plus 3. That would be wrong. That would be distance. It will not be displacement. So if you want displacement, what it would be? Pretty obvious. You have understood that. It's 5 meters, and you can see here. But the direction is different. So that's the conclusion of it, that simply adding or subtracting things will not work here in 2 dimensions. We need a different strategy. We need a different understanding or a different level of understanding so that we can apply the concepts very clearly. So friends, we are going to start with the directional property, that is, we are going to start with vectors and scalars. Till now, we have got a glimpse of it, but in this lecture, we will be dealing with it in detail. So let's start with the physical quantities. Now, what is a physical quantity? Anything in universe which you can feel, measure or see, touch, that is known as a physical quantity. And every physical quantity can be measured. This is what we have studied in chapter 2, that is units and measurements. And any physical quantity will have a magnitude along with a unit associated with it. That's what we have understood. Also, there were some cases where there will simply be magnitude, but there will not be any unit. All those cases are done. We are going to understand that quantities can be bifurcated into 2, that is a scalar quantity and a vector quantity. Now, what is the basis? It's the same as the example we discussed. When you say that 4 liters of water plus 2 liters of water, it becomes 6 liters. That is a scalar quantity. There's no direction associated with the volume. Yes, so it can be simply added. It's a magnitude, right? So scalar quantities can be described using magnitude only, right? Whereas when you talk about the vectors, that is 4 meters along north and 3 meters along east, will not make it 7 meters. It will be 5 meters of displacement along somewhere northeast, maybe, or some angle with the east, but somewhere in between north and east. So that is not precise. That does not involve only magnitude, that involves direction as well. So when you have 2 things, that is magnitude, along with that a direction, then this is known as vector quantity. Let me give you another example. Suppose there is a boy who is running with a speed of 50 meters per second. Now, if you just want to know the magnitude, it's a speed that is 50 meters per second. But The other question which will come into your mind is, what is the direction? Is it north, south, east, west? I don't know. So when you associate a direction with it, let's say east, now it becomes 50 meters per second in east. That becomes a vector quantity where there is a magnitude of 50 meters per second and a direction. We will be dealing everything about the vectors. We will study that in detail, and after today's lecture you will be able to categorize that this is a particular kind of physical quantity and these are the properties. I hope you will enjoy this lecture. Stay tuned. Let's move ahead. Starting with the very first thing, that is scalar quantity. As per the point, you can see that the physical quantities have appropriate unit and a magnitude, as we have studied in chapter 2. Now, if you see the second thing, that they can be added or subtracted, it's easy. That if you can take out 2 liters of water from 4 liters, the 2 liter will be remaining, right? And in that case, if you understand that only similar quantities can be added or subtracted, obviously you cannot subtract 4 kg from 6 liters. It's not possible. The quantities having same units, only they can be added or subtracted together, right? But what about the quantities which do not have a same unit? In that case, what should be done? In that case, friends, they can be divided and multiplied, but they can't be added or subtracted. So let's have a quick revision of what we have understood. So the physical quantities which have only a magnitude and appropriate unit are known as scalar quantities. Then these quantities can be added or subtracted using the rules of simple algebra. Okay, that is simple addition and subtraction works here. And these similar quantities can be added or subtracted, but the quantities having different units can only be divided or multiplied with each other. They can't be added or subtracted. This is what you have known about scalars. Now it's time to understand the vector. A vector quantity is a quantity which has a magnitude and a direction associated with it. But there are some prerequisites. Not everything which is having a magnitude and a direction will be called a vector. For example, current. Current has a magnitude and direction, but it is not called a vector. I hope at the end of this you will be able to understand why it isn't so. Now here, the physical quantities which have both magnitude and direction, that is the first prerequisite. And the second is, they should follow triangle law or parallelogram law of vector addition. What are these laws? You will study this in the second lecture of this chapter. But if these two things are not followed, you cannot say a physical quantity to be a vector quantity. So the third point is the same. So what are the examples of these? Like force, velocity, displacement. All these things have a magnitude and they follow triangle law of vector addition or parallelogram law of vector addition. So what about current? Why doesn't it follow that? Suppose there is a junction, right? And current is coming from here and definitely some current will move on. So just assuming this is 4 ampere and this is 3 ampere which is coming on. Now, what would be the current which will be going forward? You tell me. Yes, you have studied this in 10th class. Obviously, this would be 7 ampere without doubt. Now, what is the angle between them? Let's say it is 60 degree. First thing, if I change the value of 60 degree to 30 degrees, will the answer change? No. If I make it 120 degree, will the answer change? No. If I make it 90 degree, will the answer change? No. That means the angle between two current directions doesn't matter what the result will be. Result will always be 4 plus 3. That means there is no application of triangle law. Yes, friends. And that's why current, in spite of having a magnitude, a direction, it is not counted as a vector quantity. It is a scalar quantity. Similarly, pressure, surface tension, all these things are scalar quantities in spite of having the magnitude and direction. I am reiterating the same, that they should have two things. First is the magnitude along with the direction, and second being they should follow triangle law or parallelogram law of vector addition. Quantities other than that, you will call them a scalar quantity. Just like current, pressure and surface tension are also some of the physical quantities which, in spite of having the magnitude and direction, are known as scalars. So I hope you have understood this. Now in our next video, we will understand how to represent these vectors.